Okay, these are the notes for the natural base E notes that you have. Essential question is, how do you find the asymptote of a natural base function? So our main idea today is natural base. And so the natural base E, so E actually represents a number. It represents this number approximately 2.71828 blah, 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 blah. Okay, and it starts repeating. Or not repeating actually. And it is irrational. So anytime you have a decimal that goes on forever and never repeats, it is called an irrational number. Now, E looks like a variable if you just look at it, but variables mean they can have different, X can have multiple numbers depending on the problem. E has a very specific number. It's 2.718 blah, 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 and we call this natural base. So, simplify each expression. So even though E has a specific number, when it says to simplify, that just means that we use some sort of rule to help make it a little simpler. It doesn't mean to plug it in your calculator and get a value. Remember, that's evaluate. So what this means is we are going to use some of our exponent rules. So since we can treat it like a variable, then we're going to do our exponent rules. So just to remind you, part A. So e to the second times e to the fifth. What do we do to the exponents in this case? Right, so we should add them. So then you get e to the seventh. Now this actually has a value. You could plug this in your calculator because you do have an E button on your calculator. It's above the LN button that you have. So if you look above the LN button, you'll see the little shift. If you hit shift LN, you'll get the E value. Okay, but we're not evaluating, we're just simplifying, so that's your final answer. Okay, part B. So again, simplify, we're just using the exponent rules. So remember, in this case, you can divide the coefficients. So 3 goes into 12 4 times. And since the bigger number's on top, then 4 is on top. Okay. Then we have these. So remember, when you have the same base and they're on different levels, one's on top, one's on bottom, you subtract. So 4 minus 3 is 1. And then it would go on top because that's where there's more. So e to the first, but remember, we don't typically have to put that one exponent. Okay, and then part C. Here, when we have an exponent outside, what are we supposed to do? Well, this is 5 to the first, so that means, remember, we distribute that. We multiply the exponents. So that means it'll be 5 to the second power and e to the negative 6x power. Then we just clean it up. So 5 to the second power is 25, e to the negative 6x power. That's as far as you can simplify it. Now this one we actually couldn't type in our calculator because we have this x value, x variable. Okay, so e, even though it represents a specific number, 2.718 da da da, if it says simplify, we can still use the exponent rules if it's the same base, because it's a natural base. Okay, now here they want us to actually evaluate the expression. So this you will plug in your calculator when it says evaluate. Okay, so your calculator should have an LN button. And if you look above the LN, you should see an E to the X probably. Okay, so you'll have to hit Shift LN, which LN represents for natural log, something we'll talk about in the second part of chapter 7. So to get to the natural base, you have to hit Shift or second LN to get this. Okay, so go ahead and practice that on your calculator and see if you get the pieces that you should be getting. All right, so check your answers, and these are the numbers you should have gotten. Typically, we like to round to 2 decimal places. This was 0.599, I believe it was, and so that 9 would bump it up. Instead of 59, it would be 60. So technically, I guess I should put a 0 there. And if we were just rounding to one decimal place, then it'd be 54.6, 0.9, and 2.1. Okay, so to get to this E, you have to hit your second or your shift button and then find that LN button, and it's right above it. That's your natural base button. Okay, then we also have natural base functions. So a function of the form this, so you have some number a in front and then e to the rx, is called a natural base. Okay, if a and r are both positive, so the number in front and the number in front of the exponent is positive, then it's exponential growth. So it's this one. The a is still positive, but if the r is less than 0, so that means the exponent is negative. If the exponent is negative, then it's a decay function. So e to the positive x is a growth function. E to the negative x is a decay function. So that's how, since e, the base is the same every time, how you decide if a natural base function is growth or decay is by the exponent. Positive exponent, it's growth. Negative exponent, it's decay. Now you still tell the asymptote the same. So since there's no k value at the end here, then notice on both of these that y equals 0 is the asymptote. So same kind of thing. Since that's plus 0 at the end, no k value, then it's y equals 0. All right, continuous compound interest. So this is another formula that you'll be given, but again, all of these you will have to know. Although these aren't too bad because the A from before when we did compound interest, when this one, the reason why this one's a different formula because it says continuous compound. If it says compound yearly, monthly, etc., that was the previous one we did where it had the N in it. This one, the A value is still your ending amount. P is still the starting amount that you deposit into the account. R is still the rate as a decimal, and T is still the number of years. The only difference is now that our base is just this E. We don't have to do 1 plus something. Okay, so if it says compounded continuously or continuous compound, it is this formula. I usually call this the PERT formula because it's P-E-R-T. So P times E to the RT power. That's the PERT formula. Okay, so let's see how to use that. Again, the reason why you know this is because if you read through this, it says compounded continuously. As soon as it says compounded continuously, you're using the PERT formula. Okay, so you deposit $800. That's your principal. D is always E in this equation. That pays 6% annual interest compounded continuously. What is the balance after 3 years? So R is the 6%, which as a decimal is 0.06. The T this time is 3 years, so times 3. Okay, so you'll do 800 times E. So remember, to get the E, you hit second or shift your LN button, and then your exponent will be 0.06 times 3. Now all of this needs to be in the exponent, so if you have to put parentheses around it, please do that. All right, so when you type that in, you get approximately $957.77. This is a problem where you need 2 decimal places, which makes sense when you're dealing with money. And you have to have the dollar sign because you have to have the label for your real world problems. Okay, so compounded continuously uses this PERT formula. If it says anything other than compounded continuously, it says compounded something else, then that's when you use the other formula that we did previously that looks like this. Okay, so this is if it says compounded something else. This is if it says compounded continuously. So it's the base number that's different. And then your R is now an exponent. Okay. All right, so go ahead and try the exit slip. So pause it, try the exit slip, and then unpause it when you're ready to check. Okay, so then on this one, your principal was 4,000. E, because it's compounded continuously. 0.06 is the rate as a decimal, and then after 2 years, so you have to multiply that by 2. So you get approximately $4,509.98. It said 0.987 in your calculator, but remember, banks are greedy and they're not going to give you that extra cent. So you just cut it off. No rounding. Okay. All right, so go ahead and do a repetition and then work on your worksheet.